Hi everyone! We're going to be now applying properties of central angles and arcs to circles, so get excited. Alrighty, so let's start labeling our picture, and from there we'll piece together the properties that I mentioned in the Prezi video to help us find what we're looking for. Alright, so I'm going to zoom in on example 1 right now. So, example 1, and again, like normal, it's always helpful to label your picture because that will ultimately help you when you're solving. Guys, so it says the measure of angle AFB, which is this angle right here, is 18. So I'm going to label that as 18 degrees. Bam. So 18 degrees. Okay, and eventually I want to find the measure of arc CDE. So that is an arc. Okay, if you see it's like kind of curved like this, that means arc. And remember, since I listed more than 2 letters, that means it's a major arc, which means it's equal to 180 degrees or more. Okay, so that's something to keep in mind. Okay, so arc CDE, you have to go around the circle when you're talking about arcs. Okay, arcs can never, ever, ever go through the circle, sorry. That's what the demon cats are going to tell you to do. You can't go through the circle to get to the rest of the arc. You have to go around the circle. So when you're dealing with arcs, you must stay on the circle. No crossing through the circle. That's when a demon cat will attack you. So watch out. Guys, so ultimately we want to find arc CDE, which is this arc right here. So I'm going to highlight that bad boy so we know what we're ultimately trying to get to. So I'm trying to get to this arc right here. Guys, but you're probably looking at this problem and you're like, Miss Long, there's nothing on any of the arcs. So how could I even find any of arc CDE? I don't have anything labeled on my arc. Well, guess what, you guys? If you remember from the Prezi, central angle, whoa, I got excited there, sorry. Central angles are angles that must start from the center of the circle. So like angle AFB is one, angle BFC is one, angle CFD is one, angle DFE is one. Okay, central angles, okay, have the same measure as their arcs that intercept them. Okay, so central angles are angles in the circle that must have their vertex on the center. So if you notice, all of these have their vertex, the pointy part of the angle, on the center of the circle. Guys, so the arcs that are kind of like in front of the angle, or like the arc that starts and ends at that central angle, they are congruent. So like angle like AFB and arc AB, do you see how arc AB starts at A, which is where this angle starts, and ends at B, which is where the angle ends? So angle AFB, like if I kind of emphasize this more, angle AFB starts here and ends there. So that means that this arc right here, the arc that starts and ends where the angle starts and ends, is congruent to that central angle. This only works with central angles. So that means that this arc is 18 degrees as well. That's an 18 degrees. Guys, but that's not really going to help me find CDE, but I'm just showing you that this angle and this arc are congruent. Okay, so that was kind of poorly done, but basically I drew 2 congruent lines through the angle and through there. So this and this are congruent. Okay, so let's see if we can use that same principle to help us ultimately find arc C to the D to the E. Okay, so currently, do you guys spot this angle right here? I have a right angle, I have a little boxy drawn, which that means that this is a 90-degree angle. Okay, and then the angle, or the arc, that's intercepted by the angle, or the arc that starts and ends at angle CFD, is arc CD. So that means if this is 90, that means this arc is also 90 degrees. Cool, right? So we're getting closer. We have part of arc CD, but we need to know what DE is, so then we can find the whole arc. So let's see. In geometry, like we talked about before, sometimes you have to look within the shape to help you find things. So, do you see any angles inside of the circle that might help me find? If I could find this angle, that means that this angle is congruent to DE, this arc. Okay, guys, because this central angle DFE starts here and ends here. So these two are congruent. So if I knew that, then I'd be golden. So let's see. Can anything in the picture help me? Do you guys see it? Do you see it? Do you spot some vertical angles? I do, I know. I see them too. Okay, so these are some vertical angles right here. I'm going to pick a different highlighter color so you're not confused with the orange I've already used. I'm going to use purple. Okay, so here, these are vertical angles because they make the X. They make the famous X right here. Oh, so these two are vertical angles because they make that famous X shape. Okay, so how do vertical angles relate to each other? Gee willikers, they are congruent. So angle BFA is 18 degrees. That means angle DFE is also 18 degrees. Holy hot dog, you guys. I'm getting excited. Which that means since we know that central angle, that means the arc that is intercepted by the angle or within, if I were to extend this angle, which my marker's running out, the arc is like in between the angle. Or you can think about it as the arc that starts and ends where the angle starts and ends. That means that these are congruent as well, which means this is 18 degrees. Oh man, we're close, you guys. So if we use the arc addition postulate that you guys learned about in the Prezi video, okay, we know that the measure of arc CD plus the measure of arc DE equals the measure of arc C to the D to the E. Alright guys, so guess what? We just need to fill in our values and we'll be donezo with this problem. Alright, let's get going. Guys, so CD is 90 degrees. Okay, plus DE, which is 18 degrees. Which equals the measure of CDE. Okay, so the measure of CDE equals 90 plus 18, which is going to give me 108 degrees. Nifty, right? And guess what, you guys? This problem is donezo. Nice. And it helps you to label that these two were vertical angles. Like I could have said that the measure of angle AFB is congruent, which I'm out of space, so I'm going to write down here, the measure of angle DFE because they're vertical angles. So that's how I knew that those were congruent, if that helps you. Guys, so again, be careful. Angles can go through the circle. Arcs cannot. Arcs go around the circle. Angles go through the circle. So be careful. All right, and that is it for that problem. Wasn't that fun? Circles are my favorite. They're awesome.